Yeah, hello students, greetings of the day. This is your Anira of Faculty and Physics from VIP classes. Okay, yeah, today we'll talk about maxima and minima. Last class we have seen in case of differentiation part 1. You can go through my video. Okay, so what is differentiation and what are the formulas and its application in physics we have seen. Okay, now coming for maxima and minima. See, if you say when a function becomes maximum and when a function becomes minimum, and conditions for maxima minima we are going to talk in this class. Okay, now if you see, if I take any function y is equal to f of x, any arbitrary function, okay, so we have seen last class y is equal to x square graph kind of thing, right? So if you draw any particular arbitrary function f of x, okay, so its value will vary, y and x value will go on, will vary here. Different values for x, different values of y exist. So at a particular value of this particular value of x, this particular value of y existing, right? And its y value is what varying here and becoming maximum at particular value and minimum at particular value, right? So you can say this is maximum value of y at this particular value of say some x1, and this is minimum value of y say for particular value of some x2. Okay, any arbitrary function. So what is happening at a maximum and minimum? If you see yx graph slope, if you consider it maximum and minimum, so if slope means what, you draw a tangent for any curve here at maximum here and its minimum also here. So if you see slope of this horizontal line, how much? Slope is equal to here 0. Slope means what you said, so dy by dx variation of value of y with x is 0. Here also slope means here dy by dx value is equal to 0, m is equal to tan theta is equal to dy by dx is equal to 0. That means at maximum and minimum, okay, we're getting at maxima and at minima slope of yx graph, okay, slope of yx graph, how much coming beta? That is equal to 0 here. Slope, first derivative slope means here, okay, variation value of y with respect to x, that is change in value of y with respect to x. That's what we are calling delta y by delta x. When delta x is very small, that is called dy by dx, instantaneous change we are calling. So at maximum and also at minimum the slope value is 0. So what happens in the neighborhood of maxima and minima? Neighborhood means just before this maxima and just after maxima. If you see just before maxima, if you draw a tangent here, the slope here to this point, if we consider this angle is acute angle theta less than 90, so slope is positive, and at maxima slope is equal to 0. Okay, so if you consider rate of change of slope at maxima, what we are talking, rate of change of slope. Rate of change of slope means what? D by dx of slope. Slope means here dy by dx. So this is change, rate of change. So change how much here? Now if I'm just before maxima slope is positive and at maxima slope is 0. So change in slope. So change in slope or variation of slope. Okay, how it is changing now here? That is at maxima it is 0 minus just before it is what? Just before it is positive. So variation slope, change in slope. Okay, so rate of change of slope. So how the slope is varying here? Here slope is positive, slope is 0. So change of slope, rate of change of slope, how much you know? 0 minus negative is what? 0 minus positive, sorry. So at maximum 0, at just before maxima it is positive. So change is at maxima 0 minus just before it is positive. So change becomes what here? Negative. So rate of change of slope means what? D by dx of dy by dx. How much becoming this now here? D square y by dx square, becoming negative. In physics or in mathematics, negative means what? Something less than 0. So you can say at maximum, so slope of yx graph means we are saying first derivative dy by dx is 0 and second derivative or d square y by dx square value becoming what? Negative or less than 0. Okay, not only just before, you can also say at maxima 0, after you can take at maxima 0. After you are having, if you draw a tangent, if you draw a horizontal, is up to the angle. Slope is negative. So negative, final value negative, at maxima 0, so change is negative. Negative means less than 0. So you can see here. Okay, similarly at minima also if you see, so as you have seen y as a function of x variation, right? So if you say any function here at this value, Slope here also. How much slope here also is equal to 0? Variation of y with x we are talking. Yes or no? Slope 0. And just before minima, slope if you consider this angle, if you draw a tangent, if you consider this angle here, this angle again here up to the angle, negative slope. And at minima it is 0. So it's rate of change of slope if I talk. How much would I talk? Rate of change of slope. Yeah. Rate of change of slope at what? At minima. That is, we are going to talk about d by dx of dy by dx. I am going to talk here, which is just before minima it is negative, at minima 0. So change is 0 minus of negative becomes what here? Positive. So rate of change of slope, okay, at minima. Just before minima it is negative, at minima becoming 0, rate of change. So variation of slope. So d by dx of dy by dx. How much becomes? This becomes positive. That means here d square y by dx square. Something positive means what? Greater than 0. And at minimum slope how much? 0. So therefore condition for minima is its first derivative slope value must be equal to 0, and second derivative d square y by dx square value how much? Becoming greater than 0. So this is the condition for minima. So any function if it is given, so find its maxima and minima if they say. So take that function, do its first derivative is equal to 0, some value of x you will get. Perform second derivative, substitute that value of x. If it is less than 0, maxima, greater than 0, minima. Okay, let us see one question now. So this question, y is equal to some x of x cube. Let's see this question. Find the maxima and minima value of this function. Y is equal to x cube minus 6x square plus 9x minus 8. So if I take the function y is equal to x cube minus 6x square plus 9x minus 8. So this function maxima value and minima value we have to find out, right? So for any function to become maxima or minima, what you should do? First of all, first derivative is 0. So perform first derivative of this one, sir. D by dx of how much? X cube minus 6x square plus 9x minus 8. Make it equal to 0. How much will you get? Yeah, d by dx of x cube is 3x square minus 6 into d by dx of x square is 2x. 6 into 2 is 12 plus 9. This is anyhow 0. Okay, make it equal to 0. So we'll have, if we take 3 common here, x square minus 4x is equal to 0. Solve for x square, 3x square, no factor a, so you can write minus 3x minus x plus 3 is equal to 0. The x common, x minus 3 minus 1 common, x minus 3 is equal to 0. If I take overall x minus 3 common, students, here, what will you get? Into x minus 1 is equal to 0. So x will be either 3 or x is equal to 1. So two values are existing for x where first derivative becomes 0. See, first derivative of a function is 0, both means slope here, slope of the yx graph is 0 both at maxima as well as minima. Now how to confirm which whether function is maxima or minima at x is equal to 3 or x is equal to 1? That's why to confirm, let us take variation of slope. That means d by dx of dy by dx, second derivative. So now just now we have seen first derivative dy by dx value. How much we got here? First derivative value after differentiation this function. Yeah, 3x square minus 12x plus 9. 3x square minus 12x plus 9. Again differentiate this one. So we'll do d square y by dx square is 3 into d by dx square 2x minus 12 into 1. This is 0. Okay. Now this derivative, if you see, this coming out to be 6x minus 12. Now find its value at those two values of x where you got. Okay. So d square by dx square, if I find that x is equal to 3, you can calculate the value. 3 means 6 into 3 minus 12. 18 minus 12 is 6, which is positive. So second derivative at x is equal to 3 coming as positive. So second derivative is positive. Function becomes what? Minimum. Therefore, y is equal to f of x or given function is minimum at what? At x is equal to 3. Okay, how much that minimum value? Substitute that value of function at x is equal to 3. So the function value actually y is equal to x cube minus 6x square plus 9x minus 8. So y is equal to x cube minus 6x square plus 9x minus 8, right? Yeah. So if substitute value of x over here, we get the minimum value. X is equal to 3 means 27 minus 6 into 9. 54 plus 9 3 is 27 minus 8. 27 plus 20, 54 minus 54 get cancelled. You got how much? Minus 8. So this is the what value? At x is equal to 3, function become minimum. This is minimum value. Minimum value of function. Minimum value of function. Okay. Now if you substitute here, x is equal to 1. What will you get? X is equal to 1 if you substitute. 6 into 1 minus 12. What will you get? D square y by dx square. At x is equal to 1 if you substitute. What are you going to get? Come on, tell me. 6 into 1 minus 12. How much? 6 into 1 minus 12 is minus 6, which is less than 0. Yes or no? Less than 0, function becomes what? Maxima. Therefore, maxima at x is equal to 1. How much that maximum value? You can substitute that value of in y is equal to f of x function. So the function value x cube minus 6x square plus 9x minus 8. Put x is equal to 1. 1 minus 6 plus 9 minus 8. 10 minus 6, 4 minus 8 is minus 4. So the maximum value is minus 4 and minimum value is how much? Minus 8. Okay. So like this, when a function is given, do first derivative, perform equal to 0. Then we get two values of x here. And at what value of x function maximum or minimum? For that, do second derivative. Substitute the value of those two values of x. If x is greater than 0, function is minimum. Substitute that value of x, we will get minimum value. Similarly, maximum, second derivative x is equal to other value you can do. If it is less than 0, function becomes maximum. How much maximum value? Substitute that function value in the given function y here. Okay, so that we will get maxima and minimum value of a given function. Okay, so like this, what we'll do? So we'll find maximum of a function, minimum of a function. So where we make use of this particular value, okay, in physics, like we come across in gravitation, we have 2-point masses. If say application in physics, of course, in the first year you won't understand. Yeah, gravitation chapter we have to discuss. And same question, electrostatics also. Like a point, some mass is here. So if you remove some small mass from this one, so this total mass capital M we can say. If you remove small mass, that's removed mass small m and a residual mass capital M minus small m. If you place at what distance, the force between them becomes maximum. For what value of removed mass or fraction of mass for a given distance of x, the force becomes maximum. Okay, so when you remove small mass m and if you kept here capital M minus small m, small distance x for a given value of x, how much value of mass you have to remove, so that you can ask the question later. For the what ratio of m by m, the force becomes maximum. Becomes what? Maximum. So we'll do this proceed problem here like this. The gravitational force between these 2-point masses will be G capital M small m by x square. This force becomes maximum. It depends on mass, isn't it, for a given distance. So we will use the concept of maximum minimum here, dy dx. Okay, so d by df by here dm. Why? Force depending on mass for a given distance. So you can do df by dm is equal to 0. Okay, if you do here, what will you get? G constant. Okay, x also constant. So d by dm of open this bracket, capital M into small m minus m square is equal to 0. So this becomes 0 here. So if the differentiate m into 1 minus 2m is equal to 0, So m is equal to m. If you remove the mass exactly half of the original mass, and if you separate them some distance x, the force becomes maximum. Same question electrostatics also. Some small value of charge q. If you remove small value of charge q, so remaining charge will be q minus q. And it's q minus q and removed charge. If you place some distance x, that force becomes maximum when that removed charge is equal to half of the original charge. Okay, like this. And in electrostatic we have seen where the value of field because of uniformly charged ring on axis becomes maximum. Something become a maximum means do it first derivative. 0, mostly to get the answer. Okay, like even more in kinematics you can see this kind of application. A particle is thrown with some velocity u. Okay, find the time after which, okay, so its height attained becomes maximum. When you throw a particle upwards, the displacement equation what you can give ut minus half gt square. Find the time after which height becomes maximum, or find that height value. So height become maximum, displacement become maximum as a function of time. So you can do here s r h here, that is equal dh by dt, make it equal to 0. What will you get? So which is equal to dh by dt or ds by dt is u into 1 minus to 2t. Make it equal to 0. So u minus gt is equal to 0. So u is equal to gt. So t will be is equal to u by z. This is the time after which height becomes maximum, h become maximum. How much that maximum value? Substitute in this equation now h value. How much t? U by z. So u into u by z minus half into z into u square by z square. So u square by z minus u square by 2z. This becomes u square by 2z. This is the maximum height attained. Already we have done this derivation in kinematics. When you throw a body vertically upward, how much height attained? U square by 2z. Okay, so like this, as chapter comes, we'll discuss the applications of what maxima, minima. Okay, so right, yeah, so this is our concept of maxima and how to find maxima and minima. Okay, so at maxima slope 0, minima slope 0, just before maxima slope positive, at maxima 0, at just before minima slope is here negative, obtuse angle, and at minima slope is 0. So rate of change of slope we will talk, and we do the values. Okay, right. So hope you understand this, and please do subscribe and like my channel and forward it to others. Okay, yeah, thank you all. So we'll stop here, and next class I will take some numericals and application of derivatives and concept of integration. Okay, yeah, thank you.